Hello student. So today we will learn about dipole moment. Now before we know about dipole moment, we should learn about the how the polarity develops in a bond and about the polar bonds. Now if we talk about say a heteronuclear diatomic molecule, if we talk about an heteronuclear diatomic molecule, say HCl, this is a heteronuclear diatomic molecule. Why? Because the two atoms are different, so it is called heteronuclear, and it is made up of two atoms, so it is diatomic. So this HCl is an heteronuclear diatomic molecule. Now in this heteronuclear diatomic molecule, you see that the chlorine is more electronegative than the hydrogen. So this bonded pair of electron, will get shifted towards the chlorine atom. Now if this bonded pair of electron gets shifted towards the chlorine atom, the chlorine will acquire delta negative charge and the hydrogen will acquire a delta positive charge. Okay, now because of this, a polarity will be developed in this bond. A polarity will be developed, and these types of bond in which the polarity is developed, these types of bond are called the polar bond. Okay, so for some other example we can take as HBr. This is also a polar bond. HF, this is also a polar bond. HCl, obviously we have already discussed. LICl, this is also a polar bond. So in this polar bond, the polarity will be developed because of the development of partial positive and negative charge within the molecule. Now say if we take some example of homonuclear diatomic molecule. So in case of homonuclear diatomic molecules, say for example say H2, say Cl2, or say Br2. Okay, so in case of homonuclear diatomic molecule, you see that this bonded pair of electron will be equally shared by both the atom, because both the atoms are identical, so both will have same electronegativity. So this bonded pair of electron will not be shifted towards any of the side, and so there will be no development of partial charges. So in these cases, in case of homonuclear diatomic molecule, no polarity is developed. So no polarity is developed and these types of bonds are called non-polar bonds. So now we can come to our topic of discussion, dipole moment. So what is dipole moment? The dipole moment is the extent of polarity of a covalent bond. Now as we have discussed, in case of HCl, we know that opposite charge are developed, partial opposite charge are developed, where the chlorine acquire delta minus charge and the hydrogen acquire delta plus charge. Okay, so this dipole moment mu can be calculated as delta into D, where delta is the charge developed on any of these atoms, the magnitude of charge developed on any of these atoms, and D is the distance between the two charges. D is the distance between the two charges. So we can define dipole moment as the magnitude of charge developed at any of the pole multiplied by the distance between the two poles. That is equals to the dipole moment of the molecule. Now this charge delta, this is in the order of 10 to the power minus 10 ESU, and this distance T, this is in the order of 10 to the power minus 8 centimeter. Now if we multiply this, so mu will be equals to 10 to the power minus 10 ESU into 10 to the power minus 8 centimeter. So this will be equals to 10 to the power minus 18 ESU centimeter, and this 10 to the power minus 18 ESU centimeter is called 1 dBi. and this dpi is the unit of dipole moment. So this dpi, this is the unit of dipole moment, unit of dipole moment. So now if we consider the case of homonuclear diatomic molecule, say homonuclear diatomic molecule means H2 or Cl2 type. So in this case you see that there will be no separation of charge, there will be no development of partial positive or negative charge. So in that case this delta will be equals to 0. Now if this delta be equals to 0, then delta into D, this will be obviously this will be equals to 0. So we can say that in case of an homonuclear diatomic molecule, the mu, that is the dipole moment, will be equals to 0. But in case of an heteronuclear diatomic molecule, you see that in case of a heteronuclear diatomic molecule, there will be a development of partial positive and negative charge. So if there be a development of partial positive and negative charge, so in that case this delta, this will be unequals to 0, and obviously this distance, the distance between the two atoms, this will obviously this is unequals to 0. So in this case we can say that this dipole moment mu, will be non-zero. That means in case of an heteronuclear diatomic molecule, will have some dipole moment, and this dipole moment will be non-zero. That means it will have some considerable dipole moment. Now what about in case of a polyatomic molecule? Now we know that this dipole moment mu, this dipole moment is a vector quantity. It is a vector quantity, and it is the vector sum of all the bond moment present in the molecule. Now see that in case of a polyatomic molecule, say for example carbon dioxide. Now in case of carbon dioxide, you see that you have two carbon oxygen bond. Now the bond moment of this carbon oxygen bond, you see that the bond moment of this carbon oxygen bond is acting along this direction, and the bond moment of the other carbon oxygen bond is acting along this direction. Now both the bond moment are equal in magnitude and they are opposite in direction, so they will cancel each other, and the resultant dipole moment mu will be equals to 0. Okay, so that means in case of polyatomic molecule, in case of a symmetrical polyatomic molecule, or in case of polyatomic molecule where the bond moment of all the bond cancels each other, in that case the dipole moment will be equals to 0. Okay, now see that in case of water, H2O. Now in case of water, you see that you have 4 bond moments are there. So this will be delta positive, this is delta negative, this will be delta positive. Okay, so here you have a delta negative charge on the oxygen atom. So the bond moment of this oxygen hydrogen bond will be acting along this direction, and the bond moment of this oxygen hydrogen bond will be acting along this direction. Okay, similarly you see that due to lone pair of electron, the bond moment due to lone pair of electron will be acting along this direction. So you see that here the resultant bond moment, the resultant of all the bond moment will be a non-zero number. So in these types of molecule where the bond where the vector addition of the bond moment of all the bond is a non-zero number, so in these types of cases we'll have an appreciable dipole moment. Okay, that means we can say that in case of a polyatomic molecule can either have zero dipole moment or a non-zero dipole moment. Now when it will have a zero dipole moment, if the molecule be symmetrical, then in that case the bond moment of all the bond will cancel each other. So in that case it will have zero dipole moment, otherwise it will have a non-zero dipole moment. Thank you for listening to this lecture. So thank you all.